Hi, this is Paul on the Plane, and welcome to episode 5 of our video series, Faking Space. This is part 2 of our image analysis on pictures we are told are coming from the Deep Space Climate Observatory, or DSCOVR, and its epic camera, a mere 1 million miles away. In part 1, we observed how the lunar transit series from DSCOVR provided images of the Earth and Moon in a single picture with a tilted box around it, and the box had noise that appeared to be added in, while all of the other pictures the Epic sent us from the days before and after the lunar transit in 2016 had no box, no noise, no nothing, just black paint all the way around it, proving without a shadow of a doubt that the images were simply pasted onto a black background. If you believe the tilted box with noise added later was actually a real picture, even though none of the other Epic images contained boxes or noise, why do you think NASA, or the NOAA, who is managing the DSCOVR satellite, would take the time to cut out the picture of the Earth and paste it onto a black background? We are told the Epic camera shoots a square image, 2048 by 2048 pixels, so the image we receive should be a square, not circular, or you wouldn't see the Moon approaching the Earth and leaving the frame unless it was right in front of the Earth. So there's no other logical explanation other than the images of the Earth are all pasted onto a black background. Okay, let's get into DSCOVR Part 2 here with the other gallery of images for a different lunar transit series, this one from July 16, 2015. Part 1 was the lunar transit images from July 5, 2016, so it's easy to get the dates confused. The first thing you will notice here is that it says the images from this gallery are reprocessed, which, as we discussed in Part 1, just means the colors have been enhanced. So I've taken the liberty to download the first seven images from the gallery because that is where we immediately found something rather strange about these images. Before we get into those, on a side note, when you go into the page where you can pick the date you want to see the images from, and you go back to July 16, 2015, it looks like we didn't receive any images from DSCOVR that day. Very strange. Okay, time for the big reveal. As I mentioned, the first 7 images are what I downloaded from the gallery, and here's why. Not going to use the first one because I don't think the object shows up there. I'm going to start with the second one, and very simply going to do what we always do. Going to go to the gamma brightness, and we're going to pop this thing way up. 1, 2. So we've got 2 moons. Weird, huh? Alright, let's go to the third one. Here's the third image. Fourth one. Different color, but the same shape. I think if you measured the curve here and here, you'd find that. But we're seeing that there's an edge here where the moon is coming into the frame, and we've got an edge here where it looks like another moon is leaving the frame. Very odd. Here's the fifth one. Same curve, different color. There's an edge here and an edge here. So there's maybe 2 boxes now. Let's go to the 6th one. And now the second moon is leaving the frame. And the moon that we're supposed to see is fully in the frame now. And then the 7th one. There you go. The second moon is totally left. Okay, as we wrap up Part 2 of our analysis on the DSCOVR satellite lunar transit from 2015, we're going to be pulling our photos that we've been analyzing today into forensically, looking for noise and ambient light. So just a quick reminder, if we would expect these images to be real, we should see, as you can see, this is a picture I took of the moon, which we've analyzed before, but if we go to the noise analysis tool, first of all, I wanted to do just a quick reminder of what we should see if a real picture is taken and you do this analysis. You come up and slide the opacity slider up and you see noise. This is a classic example of noise. Here is the object, and the dark areas or space around it should all have noise. And then for the ambient light, we want to slide the opacity slider up. Oops, that was too far. And then start increasing the width. And we can see this ambient light showing up around the object. You see how it gets it's light as it's real close to the object, and then gets darker and darker as you go away from it. And you can adjust that and really make that ambient light show up. And that's what we would expect to see if an object is throwing light at us, or that's the source of the light. Whether you believe, again, the moon is producing its own light, or whether you think it's reflecting, either way, we should be seeing, if light is coming from the object, we should be seeing ambient light. So, very simply, let's go back to our images from the lunar transit. We'll pull in number 3 to start. Start with the noise analysis. And as you can see, noise over the objects, in this case, 3 objects, 2 moons, 1 Earth, but no noise in any of the dark areas of space. Okay? Very, very odd. Go to level sweep. Looking for ambient light. Again, if we crank this up, we should start seeing evidence of the ambient light appearing around really all of the objects, and we see none. Same conclusion, same results, same conclusion. Ambient light is not present. These objects are pasted onto a black background. We don't see noise. We don't see any ambient light. Alright, another image analysis of photos we are told are coming to us from a 4 megapixel camera from 1,000,000 miles away, showing both the Earth and the moon, moons. So we'll wrap up part 2 of our DSCOVR image analysis with a quick recap so far. In part 1, we covered the lunar transit images from July 2016 that all had a tilted box pasted onto a black background, but the images from the days before and after had no box. The images with the moon contain noise added after the fact, and the images on the days before and after have no noise or ambient light. A year earlier, NASA only provided us reprocessed images of their 2015 lunar transit series, but these had no boxes, no noise, and no ambient light, and every single image should. But they do have something special, a second moon. Very, very strange. Okay, in part 3 of our DSCOVR series, we'll analyze images from the EPIC camera from a solar eclipse on March 9, 2016, and we'll have some interesting findings to present as well. We hope you have enjoyed episode 5 of our series, Faking Space. On behalf of Archer Sage, this has been Paul on the Plane. Thanks for watching.